Good afternoon. Today we are going to be focused on plotting. I'm going to do an example on plotting a graph. Yes, so the question that we have here, well, it starts on the other page. It starts from this first question here, but we are not going to be focused on that. We are going to be mostly focused on the plotting part of the graph. So basically, the first few parts of the question, we are just finding these values, these three values. So we have already done that. So we are focused on this question, the one that says, on the grid provided, plot a graph of C in centimeters against L in newtons. That is force against extension, basically. This is Hooke's law. Right. So moving on to our graph pads, I put them side by side here so that you can have an idea of how we do everything. So the first thing that we do, we label our axis. It says that on the y-axis, which is here, you have to plot C in centimeters. So we label on our graph that we have C in centimeters. That is our y-axis. And then moving on to the x-axis, we have to plot L, which is in newtons, or the force that is applied, or the load in this question. So our load is in newtons. We have labeled the graph. Now, looking at the values that we have, for L, our values range between 0 and 60. L is this, the ones that are on the x-axis here on our graph. So we can start labeling. We find a suitable scale that we can use. So I'm going to start with 0, 10, 20, 30, 40, 50, 60, 70, 80. So these are my values for the x-axis. That is my scale for the x-axis. Now we come to the second part, the y-axis of our graph, which is going to be these values that range from 0.0 to 5.1. So I think a suitable scale would be, this is from 0, then 1 here, and then if I put a 2 here, and then I put 3, 4, 5, such that when I plot my graph, the graph is going to cover most of my points. Okay. So with that being said, let's continue to the graph. Remember, when you're plotting a graph, we use either small cross, a dot, small dot, or sometimes a dot with a circle to indicate our points. So let's begin. The first point that we have on our graph is 0, 0. So that is 0 on the L, 0 on the y-axis. So I'm going to use crosses to plot my points. The second point is 10 on the 10 is this line. 10 coincides with 0.8. So for this ones, this is 0.5, 0.6, 0.7, 0.8. Because every two squares represents 0.1. That is, every two squares on our axis represents 0.1. So we are done with we've plotted this point here, we've plotted this one. Now we plot 20 against 1.7. So on our graph, 20 is here. 20 is here. This is 1. This is 1.5, 1.6, 1.7. It is somewhere here. So we draw a small cross. We've plotted this point. Moving on to the next point, we have On second thought, let me plot the points, and then we'll get back to it after I've plotted all of them. Okay, now I am back. I have plotted all the points that we have here on the grade that we are given. We have, I think when we left, we had 32.5, which is this point here, 30 at 2.5. Next, we have 50 at 4.2. 50 against 4.2, which is here. And then we have 60 against 5.1. So 60 against 5.1. Now, we have labeled our graph, we have chosen a scale, we have plotted our points. Now, the next or last thing that we are going to do is to use a ruler to connect them. Forgive me, I don't have a suitable ruler, so I'll be using this one. So we draw a line of best fit. What does that mean? It simply means that you have to draw a line that crosses most of the points. Most of the points. A line that passes through most of the points. Something like this. I don't know how I'm going to hold the ruler and draw the line at the same time. I'm going to hold the phone and draw the line at the same time. But I'll try. I will try. And then hold that thought. Yeah. Okay, so now we are plotting our points. So we make sure that it passes through most of the points. Starting from this one, we draw a single straight line. Okay, and then we have plotted our graph. Yes, so basically that is how you plot the graph. And then we are done with plotting of the graph. I don't think there's any other questions that we have that are related to this graph, so I think I will end the video here. Yes, I think I'll end the video